Thanks everyone for attending today. My name is Eric Stamper, and I'll be giving today's e-learning demonstration on parametric analysis with ANSYS SpaceClaim. Also, everyone is muted, so if you do have any questions throughout the demonstration, please just submit those to the chat window, and I'll try to answer those at the end of the demonstration. Okay. So just quick before we get going, an introduction about CAE Associates. We are an engineering consulting firm located in Middlebury, Connecticut, and we specialize in FEA, CFD, and electromagnetic analysis. We've also been an ANSYS channel partner for over 30 years. That allows us to provide ANSYS sales, training, and technical support. And this e-learning is one of many in our e-learning series. You can check out previous recordings either on our webpage or on our YouTube channel. We have some e-learnings already up on YouTube related to SpaceClaim. Those are related to flow domains, removing geometry bottlenecks, and there's also a kind of getting started introduction to ANSYS SpaceClaim. There's also another one on there related to reverse engineering. And of course, today's demonstration will be up there, after this. And we have also on our webpage a resource library, so you can view various case studies, presentations, update seminar presentations, and various useful information on there for you to download. We also have some macros and Workbench ACT extensions that you can check out as well. We also have a blog that we update weekly. Usually it's related to some type of engineering-related topic, so if you're not subscribed to that, you can certainly join that. And we also offer training in our office in Middlebury, Connecticut, or on-site at your location. We currently have a one-day ANSYS SpaceClaim class scheduled coming up April 10th. If you're interested in that class, you could register on our webpage. And if you are a New York or New Jersey resident, you can earn a continuing education credit for attending this full webinar. You just have to also complete the survey that's at the end of the presentation. Okay, so today we are going to be talking about parametric analysis with ANSYS SpaceClaim Direct Modeler. And this e-learning, it's focused on parameterizing SpaceClaim geometry, and specifically for a workbench mechanical simulation. So the things related to that that we'll cover are creating associativity between the mechanical simulation model and your SpaceClaim model. We can do that with name selections. We'll also talk about parameterizing geometric features, and then also script parameters. So if we just jump into the demonstration here, if we start off with our model here, so the geometry is going to come from SpaceClaim. It's linked up to mechanical. So if we look at our mechanical model, the geometry has just been imported at this point. It's just a casing. So we're going to analyze this part, and we're going to need to put some loads and boundary conditions on it. If we happen to scope some type of boundary condition to this surface, and then if we knew that we were going to perform some geometry updates, we'd want to make sure that this boundary condition stays persistent or attached to that surface as we start making changes and updating the geometry. So if we go SpaceClaim now, and say we happen to make a change to this surface, something simple like maybe we just imprint an edge. So now we have this surface that's split up into two, and maybe whatever this bolts do, it only connects or touches on this part of the surface and not this one. So we want a boundary condition that's on there. So now if we go back to mechanical and update this geometry, we'll see what happens. Geometry updates. We can see that that surface has been imprinted, but our boundary condition that we've applied to that surface is no longer scoped to the geometry. So that's not what we'd want to happen. We'd want to have that stay persistent through any geometry updates. So what I'll do is I'll just roll back these changes and go back to where we were originally. And then let me just update this again. so we can kind of start back at the beginning here. Okay, so we've imported our geometry. We have our model and SpaceClaim. So what we'd want to do to help make this geometry update stay persistent with mechanical is to create some groups. So we could do that by simply selecting on, in this case, a surface, but it could be a bunch of surfaces, edges, or bodies. Whatever you have selected, when you create a group, that will create a name selection of that surface. So let me just rename this to something we'll use, say boundary condition for that face. So if we go back into mechanical and update, the only thing that we've done so far is just define a name selection. So that shows up in here on that face. So now if we attach our loads or boundary conditions, whatever they are, to that name selection, then this should stay persistent. Since this tag surface, this name selection is coming from SpaceClaim directly. So this boundary condition is now attached to that name selection. So what that means is that if we now make changes to this surface, and we go back here again, and let's just split that surface with a circle and remove that. Now, again, it's split. But if we click on this name selection, it updates based on that change. So, it used to be this one whole surface. Now it's smart enough to detect that it's attached to both of those. So when we go back into mechanical, now that we've applied our loads, boundary conditions to a name selection, those should stay persistent and also update. Now we see we have that updated name selection. Our boundary condition stays on there. So that's what we want to do. So a more robust way to build parametric geometry and everything update is to just apply all your loads, boundary conditions, mesh settings, any post-processing objects, anything like that. If you can apply it to name selections, I'll just help you out. Now, what if we wanted to do something like this? Say go and grab all of the blends that are around here. Maybe we want to make changes to that blend radius, put some mesh controls on it, and we want to do that for all of the blends in here. So with that surface highlighted, using our selection tool, we can grab all of the blends that are that equal radius, and with all of those selected, if we use an operation like pull or move, I'll select pull. So that way it's going to pull this radius to a value. Well, we can make this value a parameter. So since these surfaces are selected, we assign pull. When we create a group, this time it creates a parameter. So now, even when we're outside of the pull tool, we can always go back to this, and then it selects all of those faces, and we can make a change to that dimension here. Let me just rename this. Call this pocket radius. And this group parameter will now show up on the Workbench project page as a parameter. So then we can go inside of here, and we could make a change to this. So let's maybe say 0.05. And then if I wanted to just refresh the geometry only in SpaceClaim, right-click and refresh that, send that parameter change. And so now this radius is a little bit larger. We can see that it's been updated here. So now that's the difference between having surfaces selected versus selecting the surface and then using like a pull or move. So if we grabbed this parameter, go off the move tool back to select, create a group. Now you see that it just creates a name selection because there was no pull or move dimension associated with that. So then we could, let's say, pocket blends. And then if we send this geometry change into mechanical, then we'll get a new name selection that radius will be a little bit larger. And now, with that name selection, maybe we put a mesh control on that. Face meshing. And then, you put something on there. So now, as we start to make changes to that radius or do various things, then that mesh control will always stay on there. So then, just another way you could create a parameter. Let's say that, there's some thickness to this casing here, and we wanted to adjust that or make that parametric. And by the way, this was just a parasolid file that was imported in here. So, it's kind of just a dummy CAD file. So we're parameterizing features in here that, otherwise didn't have any sort of parametric tie to our CAD system. So if you just take a look here real quick through the section, you can see that, maybe we wanted to adjust the thickness of all these pockets in here. So we could do something like that and make that parametric quite easily by just selecting a face. We want to grab all the faces and all these pockets, so we'll use our power select to grab all of the, let's say, coincident faces. And then with the move tool, this time if we click a direction that we want to move, and then on the little mini toolbar, if we use the ruler, we can set the height off of this bottom face. So now this 0.315 inches is the thickness of, again, the thickness of that part. So then we just go into groups, and then you can also click the little P next to this, and then that's the same thing as going in and creating a group. So now we have this parameter in here. Let's call this thickness. Again, anytime we go in here and change this thickness, it sets the move of that surface based on the bottom face. So now this is all tied into Workbench. We have a bunch of parameters. So now maybe we update this thickness in here, say 0.25, make it a little thinner. And then it can just refresh the entire project, send in that geometry change, and then it'll update our mechanical model. We can see that moved down a little bit. And then all of our mesh settings on those blends stay persistent because they're tied to name selections. Same thing, our boundary conditions. So that's the way that we'd want to go and set up our model, is to make sure that when we're performing these geometry changes, that all of our loads and boundary conditions stay on the model so we can quickly perform some design changes. Okay, so then the next thing we can do is if we wanted to parameterize a model in a slightly different way, but say effectively the same thing, we can do something similar where we create some dimensions and then we parameterize those dimensions. So to show that, I'll use this model. This is a quarter symmetry of a model of a claw. So, we have some reflective symmetry planes, this plane and this plane. And I've gone ahead and set up a bunch of constraints in here in this assembly. So you can see all of the constraints tying these various holes together. And that was just done through the assembly constraints. So this claw would be actuated by turning this screw, and then this piece here would kind of linearly translate back and forth, and closing and opening the claw. And I guess we could see that if we grab this piece here and then just move this piece from starting at the center of that hole. As we grab this edge right here, you can see that all these parts update. So if we wanted to create some dimensions of the positions of various parts here, we could do that with the detail section. And the first thing we need to do if we're going to create some dimensions is to just define the plane that we're going to dimension off of. And that's just going to be this plane right here, let's say. So I'll click that, and then I can place some dimensions between these two parts. So dimension from there. And then as we change this or move this part back and forth. Maybe we also want to know how this claw changes over here. So whatever it is, you got to put some dimensions. And if we go and then move this part right here, so select that body, use the move operation, and when I click a direction to move, then we get these little sparks that show up next to the dimensions. So meaning that these could change based on this move. So if I click in this direction, click this spark, then with that spark active, I can create a group of it. So now that's a driving dimension. So then if we go into Workbench, again, that's just a parameter. And then if I move this down here a little bit, so then maybe set this to 1 inch, and then refresh, you can see it moves this piece back 1 inch, and then we can see this parameter update over here. So again, it's just giving you another way that you can parameterize your model by changing driving dimensions. Refresh that again. And we could also have made this a parameter, and then drive that change and so on. So that's, just again, another way you can create a parameter. So then the next thing I'll show you, let's say that the geometry changes you're going to make were a little bit more complicated than just changing one parameter. Maybe you needed to do a whole bunch of steps, modeling-wise after you made that change. So if that was the case, then maybe you need to do something like scripting, which I'll show you with this example. So this is just a blank session of SpaceClaim, and I'll open up the script editor. That can be done by File, New, and Script. And then that opens this script editor. So it's still a beta. It was released at 17. It's still beta in 18, but there's still quite a bit of capability that's available in here. And it's Python-based, but I'll say you don't have to be, that good of a Python programmer to be able to use this interface. And there are a bunch of predefined APIs already in here for you. So if you know you're going to do some pull, move, fill operations, and you wanted to script that, well, there's already, the fill tool in here. You can click on that and see, it would automatically insert the code that you need to do that. There's also some examples built in. So I'm going to go into here, and I'm going to use the gear example that's already defined. But if you take a look at this on your own, there is some code already available for you to look at. So in here, these are a bunch of Python commands that will generate, in this example, a gear. So if I just go ahead and play this with this play button, I'll go ahead and make that geometry. So you see this was built from scratch through this script. Now, we may want to tie some parameters together, that are used in this script into the Workbench project page. And we can do that. And we'll show that in a second. And also, as you see, that this interface also provides feedback. So as you hover over these various lines, you can see that the geometry or the modeling window here is changing based on what I have highlighted. So you also get some nice feedback on what each of these commands are doing. So one of the lines of code here is the number of teeth. So if we go into groups, we can create a parameter by right-clicking, and maybe I'll call this parameter teeth, and I'll set the value to 20. So now we have a parameter that would show up on the Workbench project page, and if we wanted to tie that into the script that we're using, we can just type in here parameters dot, and then just the way that Python coding works, after the dot, now it shows the teeth. So it's reading off what is available for us. So that makes it nice and easy to be able to do this. And this script creates a gear from scratch. So if I go ahead and delete this gear, So that way we can replay this. We'll see that, this time it did use the parameter value that we created over here. So then if we updated this from the Workbench project page, you just open up Workbench here, you can see that we can drive this change, and we would ideally want to change this parameter and have this script run and create our gear. We're going to have to do a few steps just to make sure that all that happens. But if we look right now, what would happen is if we change this to 30, let's say 30 teeth, and refresh this, it goes into SpaceClaim and it updates that 30. But it didn't rerun this script, and also, this gear is still here, which needs to be deleted. So we would want to, also automate this process. So we'll definitely do that. But let me just start off by deleting this gear and showing you that if we did replay this, it would now have 30 teeth. So in order to get this parameter update to automatically flow through and run this script, we need to save this script into the groups. So we can do that by the save drop down here. So instead of saving it to a file, we can save it to a group. And now I'll click Save. And then it saves this script as a script group. So now we have our parameter that gets tied to that. So now, if I start off by deleting the gear, going back to our project, and then say 40 teeth this time. Now when I update this, it'll send in that change and automatically rerun the script. So that's the step that needs to be done to tie all this together. You could also, if you right-click on this script, you can pause it, so then as you update the parameters, it doesn't rerun the script as well. So now this is kind of working for us, but we need to delete this gear every time, and we wouldn't want to do that manually. So again, without knowing too much about Python or how all this works, you can record operations. So that's a great feature to be able to build your scripts. Just click this record button, and now start going in and performing operations. Say I want to select that gear, right-click, and delete it. So now the script editor recorded that operation. So that's the code that we need to delete the gear. So I could take this, just cut it, and paste it up on the top. So every time we play the script, it deletes the gear. However, at this point, though, this one body is saying that there's not a match. And if I try to play this script, it's saying, there's no body in here to select. So we would, at least in this case, need to have the gear there every time to be able to delete it. Well, maybe we want to run this script whether there's a body there or not, and just always have this work. So again, without knowing too much about Python or how to use this API, if you just delete off everything after selection here and then hit period, you can see all of the different commands that are available in here. And one of those is select all. Just like over here, I can right-click and I can always, select all, regardless of whether anything's in the model or not. We could do something like that. So we go in here, select all, and then now if we go in and play this, it can always select all, and then there's nothing to delete. So this ends up working, whether there's a body there or not. So, we just made our code a little bit more robust. And then, again, this is all connected up now, so, we could make any changes to the gear. Back to 30, refresh the project, and then it deletes the gear and recreates it. So, there's I'll say pretty easy way to go and start building these scripts is just to record operations and then start defining some parameters and then linking them up to your code. And, it's reasonably easy to figure out what's going on, these various lines. So like extrude faces in a direction of some value. Well, we could make that a parameter too. Say that our parameter is going to be thick. For the thickness of this gear, say thick equals 3. Let's say now we've defined a parameter that will get used. So this will be a little thicker if we rerun it. If we wanted that to be a workbench parameter, just right-click over here and create that parameter. Call it thickness, and we'll have 10 this time. So now go into parameters dot, and now it's again it lists all of the parameters that we have defined over here. I could type thickness, and now that's a workbench project parameter that we can update and rerun it again. So hopefully you see that it's pretty easy to start doing some of these things. And also one last thing, the nice part about this scripting interface is that you can selectively go through line by line. If we click this button right here to run line by line the code and see it executed. In this case, it's selecting all, and it's assigning that to a parameter called selection, which it highlights the selection as we kind of work through here. But we'll see one of the things that happens as we do this. It's not actually selecting this body. It gets tagged to this parameter, but it doesn't actually select it. So if you knew that whatever you needed to do, you wanted to actually select that body, again, you can just try to hunt around in here and see what's available. So we could type selection dot and see what's available, and then one of which is set to active. So set active will actually select that body. So if we go in here, run this line, run the next line, run the next one, then it selects it, keep going, it deletes it, and so on. So we'll poke around in here and see what's available. So that was basically it for today. We went through parameterizing the model with parameters, scripting, and also creating name selections. So thank you for attending this webinar. Please check us out online.